new guy here. So we're gonna begin a new series that's gonna be about algorithms, and the first one we're gonna check out, it's the Fibonacci series algorithm. I think it's pretty simple to start. We can have different solutions for this algorithm. For those you don't know about it, it's a simple series that series of numbers that you have at the beginning. You have only two numbers, 1 and 1. So you can calculate the next index, the next element in that list by adding up the previous two numbers. So if we want to get the third element on that series, it's going to be adding 1 and 1, and so the result is going to be 2. If you want to calculate the next one, it's going to be 2 plus 1, so it's 3, and the next one should be 3 plus 2, 5, and so on. So that's the Fibonacci series. So the first way we're going to try to calculate this, it's a simple straightforward algorithm. We can call it brute force because we're not doing any special calculations at all. So let's begin. We're defining our function, and the only parameter that's going to receive our function is going to be the index of the number that we want to retrieve. So that's going to be the slot on the series that we want to get to know the actual value. So let's call that index, and we only need to begin our series with the first two elements of the series. So that's going to be just 1 and 1. So let's add that. And then now we just simply iterate. We're gonna start with the element 2, and while our actual element is lower than the index that we are calculating, we're gonna continue getting the next number on the series. So we simply do it like that. So we get the previous number and we add up to the previous number of that one. So it's like that, and then when we end up getting that, we simply return the element on the slot that we're actually looking for. So let's print that out. Let's say I want to calculate the number on the third position. That's more like it. Okay, so maybe we can just do another example to make sure that it's working properly. So we had the 5. So as we can see on the series, we can do some manual calculations to make sure that we're getting the proper values. So as we can see, the fifth element, it's the actual value 5. So let's see what's our next element. And the value should be 8. So looks like it's working perfectly fine. Let's try and the next one. So it's gonna be 13. Cool. Now this is the simplest solution I can think of for a Fibonacci series. So let's try to do something more interesting. Okay, now we're resolving the Fibonacci series with a recursive function. When you use a recursive function, you always need to think about what's going to be your stopping condition. Otherwise, it's going to be infinite loop. So at least that's the way that I always try to figure it out. I need to check out what's going to be like the condition that it's going to be stopping the execution of my function. And for this case, since we are receiving the index of the slot that we want to get the actual value of on the series, and I'm gonna calculate, as before on the previous example, I'm gonna calculate each iteration of that. So my condition that's gonna stop the execution of the recursive function is gonna be when those two values are the same. So let's write that down. Whenever my index it's the same as the current step that I'm iterating through. So we have our second parameter that we need on the actual recursive function. That's going to be the step. When this happens, we simply return the actual value of our Fibonacci function. That's going to be held in the upper variable that I'm creating. So that's also going to be passed on to the next iteration of the recursive function. And we're going to initialize that with a value of 1, as we did before. And besides this, if this function is not met, we're actually executing the iteration part. So we need to send our index that's not going to be updated at all. This is going to be the same one. The step, it's going to be the next step on the list. So for the upper element, we need to actually have the add up of this element and the previous one. So right now we only have the actual element. We need the previous one. So what I can think of, we can create an upper and a lower variables. So we are gonna always have reference of the only 2 top elements of the array of the series. So the upper element, it's gonna be the sum of the lower and the upper, and the new lower, it's gonna be the previous upper. So this way, the function is gonna be called with the next 2 elements of the list. So let's give this a go. Let's give it a try. And I'm gonna check the element on the 3rd position. So that's 2, so that's good. Let's see the element on the 4th position. It's 3, sounds good. And let's check out the next. It's gonna be 5. Perfect, it's working as expected. Another way that we can think of resolving this Fibonacci series, it's with another recursive function. This is actually something that you see on the books and on the videos or tutorials about algorithms. So it's like the simpler to memorize the actual code, because it's really little code. You will see that in about a second. Just first, I wanted to review these 2 ways of resolving the Fibonacci series, so you actually know what's happening before I show you the simplified version, because I'm pretty sure that once you see it, it's gonna be the only solution that you're gonna think of whenever you are getting into resolving this problem or this algorithm in the future. So let's get into resolving the Fibonacci with the magic solution. So I'm actually gonna call this magic, because you will see it's really super simple to remember. Again, the only parameter that we're receiving, it's the actual index. So since this is also a recursive function, again, we also need to have our stopping, our tollgate to stop executing and recursing the function. So again, this has to be related with the actual size and the actual index that we're trying to process. So whenever the index that we are sending to the recursive function is less than 2, we're gonna just return the actual number. And if not, this is the magic part. We simply return and -1, and we can add up and -2. And if we try to execute this one, oops, sorry, it's not n, it's index. So we see the function, it's working. So let's just do one more before jumping into the actual explanation of this. So It's working just fine. Let's see the 7th element. So if you want to get real crazy, you can get the 10th element or even the 20th element. So you see it's not that big number, but you can see that the Fibonacci series is growing quite rapidly. So the explanation behind this magic algorithm, it's a little simpler. If you're already familiar with recursive function, it's really simple. If not, what it actually happened behind the scenes, it's something like this. Let's start simple again. Let's assume we have we're calling the function with our looking for the 3rd element. So what's happening here, it's we're actually calling a function with our n, which in this case n is equal to 3, n minus 1, so that's a 2, and we're adding the Fibonacci with n minus 2, which is 3 minus 2, and it's 1. So as we saw in the stopping method of the recursive function, whenever we are getting a value less than 2, we're gonna actually return that value. So in this case, we're getting the 1 back. And on this side, when we're calling the Fibonacci with 2, we can think of the actual function that it's called again, but now with the values of 1 and 0. So in this case, it doesn't even matter the actual value 0 because it's not part of the evaluation, but this does. So this is returning 1. So this can be seen as adding 1 plus 1, because this value it's returned to the function fib1, and this is also returned to the function that's on top. So it's adding just these 2 values, so that's a 2. So Fibonacci of 3 is equal to 2. So we can move into a different and a harder example that's going to be a 5. On this case, Fibonacci with 5, it's the same as calling Fibonacci 4 and Fibonacci 3. And this Fibonacci 3 is also the same as calling Fibonacci 2 and Fibonacci 1. I'm pretty sure you're getting the hang of this. So whenever we're hitting the final one, that's the value that we're going to return. And on this side, again, this is divided by 2. And the final value that we have on this side, it's also 1, because the 0, as we said before, it doesn't count. And then we move back to the Fibonacci 4. As before, this is divided by Fibonacci 3 and Fibonacci 2. The Fibonacci 2 is divided by Fibonacci 1 and 0, so we have also a 1 on this side. The 3 part, it's the same. It's 2 and 1, so we end up with a 1 here and with a 1 here. So with these 1s are sent back to the parent function that was used, that was called. So we have 1, 2, 3, 4, 5. So this is the actual result whenever we call Fibonacci with a 5. So as you can see, this is a kind of a simple explanation of how a recursive function works. So if you would like to do an exercise with this with a higher number, it's gonna be fun, I guess. But it's a cool exercise to do if you are actually trying to figure out what's happening with this part. So that's it. I think this is 3 different ways of you solving the Fibonacci series. I hope you learned something new. Don't forget to subscribe and give me a like, that's really helpful. And also share this video with your friends so more people can be aware of this channel. Okay, so bye world.